Good day. So today I'm going to show you how to find the resultant using head to tail method. So before we start with the method, let's first define what is a vector. A vector is something that has got both magnitude and direction. In other ways, it has got both size and direction. Maybe they can say this is 15 newtons at an angle of 30 degrees. So they gave us both magnitude and direction. Or another example, maybe they can say this is 10 newtons to the right or 10 newtons to the east, right? So it means that it has got both magnitude and direction. That is a vector. So in this particular example, we're given that we have a force that is acting 15 newtons to the positive x direction and another one that is acting 20 newtons to the positive x direction. Then they ask us to find the resultant of those two forces. So head to tail basically means that the head of one must be connected to the tail of the other one. It can be any, the other doesn't matter, but the head of one force must be connected to the tail of the other force. So before we draw them, we have to first choose our scale. So I'm going to say 1 centimeters is equals to 2 newtons. So 1 centimeters will represent 2 newtons. So I'm going to measure. So since 1 centimeter is 2 newtons, if I want to put 15 newtons, that means it's going to be 7.5 centimeters. So I'm going to draw it to the positive x direction. So I'm going to measure 7.5 centimeters. So then this is 7.5 centimeters. Right? The direction, we have to specify the direction. So the direction is at a positive x direction. And then I have to draw another one. So the head of one must be connected to the tail of the other one. So the other one that I have to draw has to be 20 newtons and 1 centimeter is 2 newtons, meaning that to represent 20 newtons, we have to draw a line of 10 centimeters. So because it's to the positive x direction, so the head of one must be connected to the tail of the other one. So I'm gonna have to measure 10 centimeters. So there I have drawn the two forces at their respective directions. Both of them are in the positive x direction in this case, right? So just before I continue, if you wanna be tutored either online or physically, online it doesn't matter where you are or which country you are at, you can still be tutored. So we offer cheap online lessons, and if you wanna be tutored physically, we can still make an arrangement. So call or WhatsApp this number, but preferably please WhatsApp this number, and then we will take it from there. So what I do is that I tutor people 5 days a week online, and I give tests once a week so that I can check your improvements. So the head of one is connected to the tail of the other one. That is why it's called head to tail method. But now when we find the resultant, we are going to do the opposite. The resultant when we're using head to tail method is always from the tail to the head instead. Now it's not going to be, so it's going to be from the tail of one to the head of the other. So the method is head to tail, but when it comes to the resultant, we have to draw it from the tail of one to the head of the other. So what do I mean? So it has to be from the tail. This is the tail, right? This is the tail of one of them. So it has to be from the tail of one to the head of the other. But I'm not going to draw it here because it's going to mix up. So I'm going to draw it on top. So, or underneath, it's still the same. So I'm going to draw from the tail of one to the head of the other. So that's my resultant. So it's from the tail of one to the head of the other. So this was the 20 newtons vector, and that was the 15 newtons vector. So now in order to find the resultant vector, it's obviously going to be the addition, but we can also measure it. But of course, it's going to give you 17.5 centimeters. So if it's 17.5 centimeters, it's going to be 35 newtons. So the resultant is 35 newtons to the positive x direction, right? That's the resultant. I hope you understand this. So with head to tail method, it's called head to tail because we connect the head of one vector to the tail of the other vector. But when it comes to the resultant, it's always from the tail of one to the head of the other. We'll go to different levels so that you can see this. You'll fully understand all the situations. Let me give you another one. So here is another example. So we are given that we have one vector which is 15 newtons to the west and another vector which is 20 newtons to the east. So we have to draw this. We'll still use the same method, the same head to tail method. So head to tail means that the head of one must be connected to the tail of the other, and I can literally start with any force that I want to. So I'm just gonna choose my scale. So in my case, my scale is 1 centimeter is gonna be equals to 1 newton. Okay, so 1 centimeter is gonna be equals to 2 newtons. All right, so this has to be to the west, so meaning that it's gonna face that direction to the left. So I have to measure, so since this is gonna be 15 newtons, I have to measure 7.5 centimeters, because 1 centimeters is 2 newtons. So 7.5 centimeters. So that is gonna be 7.5 centimeters. So it has to face to the west. Okay. So this is 7.5 centimeters. So it's facing to the west. Now my 20 newtons have to face to the east. I cannot draw it here facing to the east because it's gonna be tail to tail. The tail of one will be connected to the tail of the other. The method has to be head to tail. So, and I cannot also draw it like this because it's gonna end up facing to the west, but this thing is supposed to be to the east. So the only thing that I can do is I can start from the head of the other, right? So that the head can be connected to the tail. So I can literally draw another vector facing like this. But I'm gonna draw them a bit apart. So I have to measure 10 centimeters. So 10 centimeters because 20 newtons is 10 centimeters, since 1 centimeter is 2 newtons. So I have to measure 10 centimeters. Okay. So 10 centimeters will literally end here. So the arrow is facing this way, remember, to the east. So notice what I'm trying to do. The head of one is connected to the tail of the other, head to tail method. I can't draw them close like this because they will end up combining. The two lines will end up combining. So in order to avoid that, I just had to draw it apart. But the head of one is still connected to the tail of the other one, right? So that we can be able to see those two forces distinctively, right? So now we have to measure the resultant. The resultant is always from the tail of one to the head of the other. We're not using head to tail method. The forces is head to tail, but the resultant starts from the tail of one force to the head of the other one. So meaning that the resultant will start from the tail of one until the head of the other. So notice it starts from the tail of this one to the head of the other one. So then we just have to measure it. So of course this was the 20 Newton vector and this was the 15 Newton vector. So if we measure it using a ruler, it should give us 2.5 centimeters, which will be 5 newtons, right? But also using logic, we know it's obviously going to be 5 newtons. So this is 5 newtons. So it starts from here until there. So that's 5 newtons. 5 newtons to the east, right? So that's how we do it. So from the head of, the resultant is from the tail of one to the head of the other. But when we're drawing forces, it has to be the head of one connecting to the tail of the other one. It doesn't matter which one I start with, but I still have to make sure that the head of one is connected to the tail of the other one. And I have to make sure that the directions are maintained as well. So notice this one is 20 newtons to the east, 15 newtons to the west. So I keep that direction the same, but I must make sure that I connect the head of one to the tail of the other. So if I don't want them to mix, I just draw them apart. But notice the head of one is still connected to the tail of the other. Here is another scenario. So this one is 15 newtons to the north, the other one is 20 newtons to the west. So let me use the same scale. So it's going to be 1 centimeters represent 2 newtons. So if I draw it, I would have to measure 7.5 centimeters. So north, right? So 7.5 centimeters. Right, so it would be right there. So to the north. And then I would have to connect it because it's head to tail, right? So since I started with this one, the other one must start from the head of the previous, right? So this is 20 newtons to the west, so it means I have to measure 10 centimeters to the west. So there, notice, from the head of one to the tail of the other. The head is connected to the tail of the other, right? And then from here, I have to now find my resultant. My resultant is always from the tail of one to the head of the other, right? If we draw it backwards, it will be from the head to the tail. But remember, the method is head to tail, so the resultant is tail to head. So from the tail of one to the head of the other. So if I draw it, this is how it would be. And that's the resultant. And then from there, I now have to measure the distance. So this is 13.5 centimeters, right? Now this means that it would be 27 newtons, right? So the resultant would be 27 newtons. And then from there, you're gonna now have to use a protractor, right? So when we use trigonometry, this is 0, 90, 180, right? 270, and revolutionary is 360, right? So you're gonna have to put your protractor. Unfortunately, I don't have it, right? When we put our protractor, it has to be somewhere there, right? Then we have to measure from there and see how many degrees is this whole space. So we have to specify the direction as well, right? So if this here, it would be somewhere like 150 degrees, right? Somewhere 150 degrees. If I were to place my protractor here, it would be somewhere like 150 degrees. So then I would say my resultant is 27 newtons and 35 degrees. Now 150 degrees. Why am I saying 35? 150 degrees, right? So we always measure it from the 0 position, going that side, going anti-clockwise, right? So this direction is clockwise, right? This rotation is clockwise, and the opposite direction is anti-clockwise. So anti-clockwise, that's how we have to measure it, right? So the direction, so this would be 27 newtons, and the degrees would be 150 degrees. So both magnitude and direction is needed. So you would place a protractor and you would measure, you would find out how many degrees is it. It should be around 150 degrees, right? 150 or 155 degrees. Should be around that side. So here is one scenario, 20 newtons south, the other one 10 newtons south, the other one is 20 newtons east, right? So let's draw the one of 10 newtons. Let me represent the same scale. 1 centimeters represent 2 newtons. So in this case, 10 centimeters south. So this would be, let's just say, okay, south, right? 10 centimeters. All right. Right, so of course my arrow has to face downwards because it's south, and the other one would be 20 newtons to the east, right? So east is to the right, so I have to connect it. I have to start from the head of the previous because it's head to tail, so I have to connect the tail to the head, so it's to the east. So it would be something like, alright, there's just something that I did there, just a small mistake there. I said 1 centimeters is 2 newtons, so it means I'm supposed to measure 5 centimeters and not 10, right? 5 centimeters, so it's supposed to be right there. Okay, and the other one would be what? It would be 10 centimeters this time. All right. Okay, so from there we now have to find our resultant, right? So this is the 20 newtons force, right? And this is the 10 newtons force. So to find the resultant, we connect it from the tail of one to the head of the other, right? Remember, method is head to tail, so the resultant tail to head, right? So we're going to have to connect it from the tail of one to the head of the other. So this would be the resultant. Now we're going to have to measure it, right? So when you measure it, it should be, so it should be around 11,1, right? So from there, 11,2 centimeters. Now when we represent that in newtons, it's gonna be 22,4, right? So it means this is gonna be 22,4 newtons. And of course, you're gonna have to now specify the direction, right? So notice the arrows towards that side. So we're gonna have to specify the degrees. So if you use a protractor, notice if you go clockwise, right? If you go clockwise, it would eventually pass 180 degrees, because 180 degrees would be somewhere there, 0 degrees would be somewhere here. So it would eventually pass 180 degrees. So you're going to have to continue. So it means you're going to have to turn the protractor upside down, and then you're going to have to measure this part. So it should be around somewhere like 330 degrees, right? So it's going to be 330 degrees. So the issue we had there is we had an arrow facing this way, and when we use a protractor, 0 starts from here, so we're going to have to go all the way, right? All the way. So it should be around 330 degrees or 340 degrees. Here I'm just playing guesswork because I don't have a physical protractor, but I hope you get it. So when we measure it, we're trying to measure the direction of this arrow, right? So 0 starts from there. So we're going to have to go all the way, right? Just like what I did here. 0 starts from there. So the horizontal part is 0, right? From the tail of one, if you connect the protractor horizontally, 0 would start from there. So you're going to have to go all the way up until it touches there and measure the degrees. So you're going to now have to flip it, because we know eventually it's going to reach the full length of it, which will be 180 degrees this side. Now we're going to have to flip the protractor upside down and measure how far will it go. So it should be around 330 degrees. You can even measure the degrees, and let's just say it was something like 150 degrees. So if you say 150 degrees, then you add it to 180, it will give you 330 degrees. So if you turn it upside down, whatever you measure there, you would now have to add 180 to it, right? You now have to add 180 to it. So when you turn it upside down and it gives you something like 150, if you say 150 plus 180, it will give you 330, because of course the protractor doesn't have those big degrees like maybe 190 or 200. It stops at 180. So when you flip it upside down, we now have to measure it, and the answer we get, we have to add 180. So I hope you get this part, because we have passed 180 already. So when you turn the protractor upside down, when we measure it, the answer we get, we have to plus 180. Here is the last level. So if we're given 4 forces, let's just say we're given 4 forces, and we're asked to calculate the resultant using the head to tail method. So we're gonna have to draw all this, right? So let's begin to draw. So I'm gonna use, my scale is gonna be, let's say 1 centimeters would represent 10 newtons. So in this case, or rather let's just say 1 centimeters represents 20 newtons. In this case, 200 newtons would be 10 centimeters, right? So it's going to be 10 centimeters. So I'm going to have to draw a line of 10 centimeters at 45 degrees. So if I were to start here, I would have to use a protractor and measure 45 degrees. 45 degrees would be literally somewhere there. So now I would have to measure 10 centimeters, right? So 10 centimeters would be somewhere there. Yep. Alright, I might have to bring this down. Yep, I might have to bring it down. Let me just bring it down just to add some space there. So let's just say I choose to start here. So of course, if I use a protractor, right, 45 degrees would be somewhere there. So if I measure 10 centimeters, it's gonna be right there. Okay, so now let's say okay, let's draw the next one. So of course I started, so this is the tail and this is the head, right? Now I have to draw the other one starting from the head, right, so that the head can connect to the tail. So this is 100 newtons at 135 degrees, so I would have to start here. So 135 degrees would be somewhere there, right? 135 degrees if you use a protractor. So if this is 100 newtons, it means it's gonna be 5 centimeters because of my scale. So I'm gonna have to measure 5 centimeters. And then we have it. Alright, and then now we have to draw the next one, which is 15 newtons. So 15 newtons at 270 degrees. So 15 newtons in this case, so it would be 2.5 centimeters. So 2.5 centimeters would be somewhere there at 270 degrees, right? Because if you use a protractor, and let's just say you use a protractor, it's gonna be more than 180 degrees, so you will have to turn it upside down, and you would have to measure 90 degrees upside down, so that can be 270. Besides, remember 270 is there, right? This one is 0, this is 90, and this is 180. So 270, it's like vertically downwards. Alright, and then the next one is 20 newtons at 180 degrees. So 20 newtons at 180 degrees. So if you use a protractor, 180 would be somewhere there, right? So 20 newtons, you're gonna have to use, okay, 180, it's right there. So 20 newtons would be somewhere there. It ends here, literally. And then we have it, all my 4 forces. Now the resultant is always from the tail of one to the head of the other. So let me draw my resultant force right there. So that's gonna be right here. And if we measure it, it's gonna be how many centimeters? That's gonna be 7 centimeters, right? So 7 centimeters. Now we have to convert it to the forces, right? So 7, that's gonna be 140, right? So it's gonna be 140. We have 140 newtons. So there we have it, 140 newtons. But here's an issue. I only got the magnitude. We also need the direction. So if you use a protractor, right? Let's say you use a protractor to measure this stuff. This would be around 85 centimeters, right? 85, not 85 centimeters. I mean 85 degrees, right? If you use a protractor, so it's close to 90 degrees. So we would then say it's 140 newtons at what? At 85 degrees. Okay, this looks really close to 90. I'm playing guesswork, remember. This looks really close to 90. Let's just say it's 88 degrees. But of course, when you do this stuff, you now have to use accurate measurements. So there we have it. There we have it. So you basically draw one by one and make sure that the head of one connects to the tail of the other, right? And whenever you find the resultant, it must start from the head of the tail of one to the head of the other. For example, if the head of one of the forces is here and the tail of one of the forces is right there, let's just say it connects to several forces. Let's just say several forces like that. Let's just say this was our diagram. Then your resultant has to be from the tail of one to the head of the other. So your resultant would be this space. You would now have to measure the magnitude and the direction. And we have it. So we end it here.